Wi-Fi is a family of wireless network protocols based on the IEEE 802.11 family of standards, which are commonly used for local area networking of devices and Internet access, allowing nearby digital devices to exchange data by radio waves. These are the most widely used computer networks, used globally in home and small office networks to link devices and to provide Internet access with wireless routers and wireless access points in public places such as coffee shops, hotels, libraries, and airports to provide visitors. Wi-Fi is a trademark of the Wi-Fi Alliance, which restricts the use of the term Wi-Fi certified to products that successfully complete interoperability certification testing. As of 2017, the Wi-Fi Alliance consisted of more than 800 companies from around the world. As of 2019, over 3.05 billion Wi-Fi-enabled devices are shipped globally each year. Wi-Fi uses multiple parts of the IEEE 802 protocol family and is designed to work seamlessly with its wired sibling, Ethernet. Compatible devices can network through wireless access points with each other as well as with wired devices and the Internet. Different versions of Wi-Fi are specified by various IEEE 802.11 protocol standards, with different radio technologies determining radio bands, maximum ranges, and speeds that may be achieved. Wi-Fi most commonly uses the 2.4 GHz, 120 mm, UHF and 5 GHz, 60 mm, SHF radio bands. These bands are subdivided into multiple channels. Channels can be shared between networks, but, within range, only one transmitter can transmit on a channel at a time. Wi-Fi's radio bands work best for line-of-sight use. Many common obstructions such as walls, pillars, home appliances, etc. may greatly reduce range, but this also helps minimize interference between different networks in crowded environments. The range of an access point is about 20 meters 66 feet indoors, while some access points claim up to a 150 meters 490 feet range outdoors. Hotspot coverage can be as small as a single room with walls that block radio waves or as large as many square kilometers using many overlapping access points with roaming permitted between them. Over time, the speed and spectral efficiency of Wi-Fi have increased. As of 2019, some versions of Wi-Fi, running on suitable hardware at close range, can achieve speeds of 9.6 Gbps, gigabit per second. A 1985 ruling by the U.S. Federal Communications Commission released parts of the ISM bands for unlicensed use for communications. These frequency bands include the same 2.4 GHz bands used by equipment such as microwave ovens, and are thus subject to interference. In 1991 in the Netherlands, the NCR Corporation and AT&T invented the precursor to 802.11, intended for use in cashier systems, under the name Wave LAN. NCR's Vic Hayes, who held the chair of IEEE 802.11 for 10 years, along with Bell Labs engineer Bruce Touch, approached the Institute of Electrical and Electronics Engineers, IEEE, to create a standard and were involved in designing the initial 802.11b and 802.11a specifications within the IEEE. They have both been subsequently inducted into the Wi-Fi Now Hall of Fame. At about the same time in Australia, a prototype test bed for a wireless local area network, WLAN, was developed in 1992 by a team of researchers from the Radiophysics Division of the CSIRO, Commonwealth Scientific and Industrial Research Organisation, in Australia, led by John O'Sullivan. The first version of the 802.11 protocol was released in 1997, and provided up to 2 Mbit/s link speeds. This was updated in 1999 with 802.11b to permit 11 Mbit/s link speeds. In 1999, the Wi-Fi Alliance formed as a trade association to hold the Wi-Fi trademark under which most IEEE 802.11 products are sold. The major commercial breakthrough came with Apple Incorporated adopting Wi-Fi for their iBook series of laptops in 1999. It was the first mass consumer product to offer Wi-Fi network connectivity, which was then branded by Apple as Airport. This was in collaboration with the same group that helped create the standard, Vic Hayes, Bruce Touch, C's Links, Rich McGinn, and others from Lucent. Wi-Fi uses a large number of patents held by many different organizations. Australia, the United States and the Netherlands simultaneously claim the invention of Wi-Fi. A consensus has not been reached globally and is a controversial topic. In 2009, the Australian XRO was awarded $200 million after a patent settlement with 14 technology companies, with a further $220 million awarded in 2012 after legal proceedings with 23 companies. In 2016, the XRO's WLAN prototype testbed was chosen as Australia's contribution to the exhibition A History of the World in 100 Objects held in the National Museum of Australia. The name Wi-Fi, commercially used at least as early as August 1999, was coined by the brand consulting firm Interbrand. The Wi-Fi Alliance had hired Interbrand to create a name that was a little catchier than IEEE 802.11b direct sequence. According to Phil Belanger, a founding member of the Wi-Fi Alliance, the term Wi-Fi was chosen from a list of 10 names that Interbrand proposed. Interbrand also created the Wi-Fi logo. The yin-yang Wi-Fi logo indicates the certification of a product for interoperability. The Wi-Fi Alliance used the advertising slogan "The Standard for Wireless Fidelity" for a short time after the brand name was created, and the Wi-Fi Alliance was also called the Wireless Fidelity Alliance Incorporated. In some publications, the name is often written as Wi-Fi, Wi-Fi, or Wi-Fi, but these are not approved by the Wi-Fi Alliance. IEEE is a separate, but related, organization, and their website has stated Wi-Fi is a short name for wireless fidelity. To connect to a Wi-Fi LAN, a computer must be equipped with a wireless network interface controller. The combination of a computer and an interface controller is called a station. Stations are identified by one or more MAC addresses. Wi-Fi nodes often operate in infrastructure mode, in which all communications go through a base station. Ad hoc mode refers to devices communicating directly with each other, without communicating with an access point. A service set is the set of all the devices associated with a particular Wi-Fi network. Devices in a service set need not be on the same wavebands or channels. A service set can be local, independent, extended, mesh, or a combination. Each service set has an associated identifier, a 32-byte service set identifier, SSID, which identifies the network. The SSID is configured within the devices that are part of the network. A basic service set, BSS, is a group of stations that share the same wireless channel, SSID, and other settings that have wirelessly connected, usually to the same access point. Each BSS is identified by a MAC address called the BSSID. The IEEE does not test equipment for compliance with their standards. The Wi-Fi Alliance was formed in 1999 to establish and enforce standards for interoperability and backward compatibility, and to promote wireless local area network technology. The Wi-Fi Alliance enforces the use of the Wi-Fi brand to technologies based on the IEEE 802.11 standards from the IEEE. Manufacturers with membership in the Wi-Fi Alliance, whose products pass the certification process, gain the right to mark those products with the Wi-Fi logo. Specifically, the certification process requires conformance to the IEEE 802.11 radio standards, the WPA and WPA2 security standards, and the EAP authentication standard. Certification may optionally include tests of IEEE 802.11 draft standards, interaction with cellular phone technology in converged devices, and features relating to security setup, multimedia, and power saving. Not every Wi-Fi device is submitted for certification. The lack of Wi-Fi certification does not necessarily imply that a device is incompatible with other Wi-Fi devices. The Wi-Fi Alliance may or may not sanction derivative terms, such as Super Wi-Fi, coined by the U.S. Federal Communications Commission, FCC, to describe proposed networking in the UHF-TV band in the U.S. Equipment frequently supports multiple versions of Wi-Fi. To communicate, devices must use a common Wi-Fi version. The versions differ between the radio wave bands they operate on, the radio bandwidth they occupy, the maximum data rates they can support, and other details. Some versions permit the use of multiple antennas, which permits greater speeds as well as reduced interference. Historically, the equipment listed the versions of Wi-Fi supported using the name of the IEEE standards. In 2018, the Wi-Fi Alliance introduced simplified Wi-Fi generational numbering to indicate equipment that supports Wi-Fi 4, 802.11n, Wi-Fi 5, 802.11ac, and Wi-Fi 6, 802.11x. These generations have a high degree of backward compatibility with previous versions. The Alliance has stated that the generational level 4, 5, or 6 can be indicated in the user interface when connected, along with the signal strength. The list of most important versions of Wi-Fi is 802.11a, 802.11b, 802.11g, 802.11n, Wi-Fi 4, 802.11h, 802.11i, 802.11 to 2007, 802.11 to 2012, 802.11ac, Wi-Fi 5, 802.11ad, 802.11af, 802.11 to 2016, 802.11a, 802.11ai, 802.11aj, 802.11aq, 802.11x, Wi-Fi 6, 802.11i. Wi-Fi technology may be used to provide local network and internet access to devices that are within Wi-Fi range of one or more routers that are connected to the internet. The coverage of one or more interconnected access points can extend from an area as small as a few rooms to as large as many square kilometers. Coverage in the larger area may require a group of access points with overlapping coverage. For example, public outdoor Wi-Fi technology has been used successfully in wireless mesh networks in London. An international example is phone. Wi-Fi provides services in private homes, businesses, as well as in public spaces. Wi-Fi hotspots may be set up either free of charge or commercially, often using a captive portal web page for access. Organizations, enthusiasts, authorities, and businesses, such as airports, hotels, and restaurants, often provide free or paid use hotspots to attract customers, to provide services to promote business in selected areas. Routers often incorporate a digital subscriber line modem or a cable modem, and a Wi-Fi access point are frequently set up in homes and other buildings, to provide internet access for the structure. Similarly, battery-powered routers may include a mobile broadband modem and a Wi-Fi access point. When subscribed to a cellular data carrier, they allow nearby Wi-Fi stations to access the internet. Many smartphones have a built-in mobile hotspot capability of this sort, though carriers often disable the feature, or charge a separate fee to enable it. Standalone devices such as MiFi and Wibro branded devices provide the capability. Some laptops that have a cellular modem card can also act as mobile internet Wi-Fi access points. Many traditional university campuses in the developed world provide at least partial Wi-Fi coverage. Carnegie Mellon University built the first campus-wide wireless internet network, called Wireless Andrew, at its Pittsburgh campus in 1993 before Wi-Fi branding existed. Many universities collaborate in providing Wi-Fi access to students and staff through the acronym International Authentication Infrastructure. In the early 2000s, many cities around the world announced plans to construct citywide Wi-Fi networks. There are many successful examples. In 2004, Mysuru became India's first Wi-Fi-enabled city. A company called Wi-Fi Net has set up hotspots in Mysore, covering the whole city and a few nearby villages. In 2005, St. Cloud, Florida and Sunnyvale, California, became the first cities in the United States to offer citywide free Wi-Fi, from MetroFi. Minneapolis has generated $1.2 million in profit annually for its provider. Wi-Fi positioning systems use the positions of Wi-Fi hotspots to identify a device's location. It's used when GPS isn't suitable due to issues like signal interference or slow satellite acquisition. This includes assisted GPS, urban hotspot databases, and indoor positioning systems. Wi-Fi positioning relies on measuring signal strength, RSSI, and fingerprinting. Parameters like SSID and MAC address are crucial for pinpointing the access point's location. The accuracy depends on nearby access points in the database. Signal fluctuations can cause errors, which can be reduced with noise filtering techniques. For low precision, integrating Wi-Fi data with geographical and time information has been proposed. Wi-Fi sensing is used in applications such as motion detection and gesture recognition. Wi-Fi stations communicate by sending each other data packets, blocks of data individually sent and delivered over radio. As with all radio, this is done by the modulation and demodulation of carrier waves. Different versions of Wi-Fi use different techniques. 802.11b uses DSSS on a single carrier, whereas 802.11a, Wi-Fi 4, 5 and 6 use multiple carriers on slightly different frequencies within the channel, OFDM. As with other IEEE 802 LANs, stations come programmed with a globally unique 48-bit MAC address, often printed on the equipment, so that each Wi-Fi station has a unique address. The MAC addresses are used to specify both the destination and the source of each data packet. Wi-Fi establishes link-level connections, which can be defined using both the destination and source addresses. On the reception of a transmission, the receiver uses the destination address to determine whether the transmission is relevant to the station or should be ignored. A network interface normally does not accept packets addressed to other Wi-Fi stations. Channels are used half-duplex and can be time-shared by multiple networks. When communication happens on the same channel, any information sent by one computer is locally received by all, even if that information is intended for just one destination. The network interface card interrupts the CPU only when applicable packets are received. The card ignores information not addressed to it. The use of the same channel also means that the data bandwidth is shared, such that, for example, available data bandwidth to each device is halved when two stations are actively transmitting. A scheme known as carrier sense multiple access with collision avoidance, CSMA/CA, governs the way stations share channels. With CSMA/CA, stations attempt to avoid collisions by beginning transmission only after the channel is sensed to be idle, but then transmit their packet data in its entirety. However, for geometric reasons, it cannot completely prevent collisions. A collision happens when a station receives multiple signals on a channel at the same time. This corrupts the transmitted data and can require stations to retransmit. The lost data and retransmission reduces throughput, in some cases severely. The 802.11 standard provides several distinct radio frequency ranges for use in Wi-Fi communications: 900 MHz, 2.4 GHz, 3.6 GHz, 4.9 GHz, 5 GHz, 5.9 GHz, and 60 GHz bands. Each range is divided into a multitude of channels. In the standards, channels are numbered at 5 MHz spacing within a band, except in the 60 GHz band, where they are 2.16 GHz apart, and the number refers to the center frequency of the channel. Although channels are numbered at 5 MHz spacing, transmitters generally occupy at least 20 MHz, and standards allow for channels to be bonded together to form wider channels for higher throughput. Countries apply their own regulations to the allowable channels, allowed users, and maximum power levels within these frequency ranges. 802.11b/g/n can use the 2.4 GHz band. In this frequency band, equipment may occasionally suffer interference from microwave ovens, cordless telephones, USB 3.0 hubs, and Bluetooth devices. Wi-Fi is part of the IEEE 802 protocol family. The data is organized into 802.11 frames that are very similar to Ethernet frames at the data link layer, but with extra address fields. MAC addresses are used as network addresses for routing over the LAN. In infrastructure mode, which is the most common mode used, all communications go through a base station. For communications within the network, this introduces an extra use of the airwaves but has the advantage that any two stations that can communicate with the base station can also communicate through the base station, which enormously simplifies the protocols. Wi-Fi also allows communications directly from one computer to another without an access point intermediary. This is called ad hoc Wi-Fi transmission. Different types of ad hoc networks exist. In the simplest case, network nodes must talk directly to each other. In more complex protocols, nodes may forward packets, and nodes keep track of how to reach other nodes, even if they move around. Similarly, the Wi-Fi Alliance promotes the specification Wi-Fi Direct for file transfers and media sharing through a new discovery and security methodology. Wi-Fi Direct launched in October 2010. Another mode of direct communication over Wi-Fi is Tunnel Direct Link Setup, TDLS, which enables two devices on the same Wi-Fi network to communicate directly, instead of via the access point. An extended service set may be formed by deploying multiple access points that are configured with the same SSID and security settings. Wi-Fi client devices typically connect to the access point that can provide the strongest signal within that service set. Increasing the number of Wi-Fi access points for a network provides redundancy, better range, support for fast roaming, and increased overall network capacity by using more channels or by defining smaller cells. Except for the smallest implementations, such as home or small office networks, Wi-Fi implementations have moved toward thin access points, with more of the network intelligence housed in a centralized network appliance, relegating individual access points to the role of dumb transceivers. Outdoor applications may use mesh topologies. Wi-Fi operational range depends on factors such as the frequency band, radio power output, receiver sensitivity, antenna gain, and antenna type, as well as the modulation technique. Also, the propagation characteristics of the signals can have a big impact. At longer distances, and with greater signal absorption, speed is usually reduced. Compared to cell phones and similar technology, Wi-Fi transmitters are low-power devices. In general, the maximum amount of power that a Wi-Fi device can transmit is limited by local regulations. To reach requirements for wireless LAN applications, Wi-Fi has higher power consumption compared to some other standards designed to support wireless personal area network, PAN, applications. For example, Bluetooth provides a much shorter propagation range between 1 and 100 meters, 1 and 100 yards, and so in general has a lower power consumption. Other low-power technologies such as Zigbee have fairly long range, but much lower data rate. The high power consumption of Wi-Fi makes battery life in some mobile devices a concern. An access point compliant with either 802.11b or 802.11g, using the stock omnidirectional antenna, might have a range of 100 meters, 0.062 miles. The same radio with an external semi-parabolic antenna, 15 dB gain, with a similarly equipped receiver at the far end might have a range over 20 miles. Wi-Fi 4 and higher standards allow devices to have multiple antennas on transmitters and receivers. Multiple antennas enable the equipment to exploit multipath propagation on the same frequency bands, giving much higher speeds and longer range. Wi-Fi 4 can more than double the range over previous standards. With Wi-Fi signals, line of sight usually works best, but signals can transmit, absorb, reflect, refract, diffract, and up and down fade through and around structures, both man-made and natural. Wi-Fi signals are very strongly affected by metallic structures, including rebar in concrete, low-E coatings in glazing, and water, such as found in vegetation. Distance records, using non-standard devices, include 382 kilometers 237 miles in June 2007, held by Hermano Pietras Amali and Es Lared of Venezuela, transferring about 3 megabytes of data between the mountaintops of El Aguila and Platalian. Wi-Fi connections can be blocked or the internet speed lowered by having other devices in the same area. Wi-Fi protocols are designed to share the wave bands reasonably fairly, and this often works with little to no disruption. To minimize collisions with Wi-Fi and non-Wi-Fi devices, Wi-Fi employs carrier sense multiple access with collision avoidance, CSMA/CA, where transmitters listen before transmitting and delay transmission of packets if they detect that other devices are active on the channel, or if noise is detected from adjacent channels or non-Wi-Fi sources. Nevertheless, Wi-Fi networks are still susceptible to the hidden node and exposed node problem. Wi-Fi allows wireless deployment of local area networks, LANs. Also, spaces where cables cannot be run, such as outdoor areas and historical buildings, can host wireless LANs. However, building walls of certain materials, such as stone with high metal content, can block Wi-Fi signals. A Wi-Fi device is a short-range wireless device. Wi-Fi devices are fabricated on RF integrated circuit, RF circuit, chips. Different competitive brands of access points and client network interfaces can interoperate at a basic level of service. Products designated as Wi-Fi certified by the Wi-Fi Alliance are backward compatible. Unlike mobile phones, any standard Wi-Fi device works anywhere in the world. A wireless access point, WAP, connects a group of wireless devices to an adjacent wired LAN. An access point resembles a network hub, relaying data between connected wireless devices in addition to a, usually, single connected wired device, most often an Ethernet hub or switch, allowing wireless devices to communicate with other wired devices. Wireless adapter. Wireless adapters allow devices to connect to a wireless network. These adapters connect to devices using various external or internal interconnects such as PCI, Mini PCI, USB, Express Card, CardBus, and PC Card. As of 2010, most newer laptop computers come equipped with built-in internal adapters. Router. Wireless routers integrate a wireless access point, Ethernet switch, and internal router firmware application that provides IP routing, NAT, and DNS forwarding through an integrated WAN interface. A wireless router allows wired and wireless Ethernet LAN devices to connect to a, usually, single WAN device such as a cable modem, DSL modem, or optical modem. A wireless router allows all three devices, mainly the access point and router, to be configured through one central utility. This utility is usually an integrated web server that is accessible to wired and wireless LAN clients and often optionally to WAN clients. This utility may also be an application that is run on a computer, as is the case with Apple's Airport, which is managed with the Airport utility on Mac OS and iOS. Wireless network bridges can act to connect two networks to form a single network at the data link layer over Wi-Fi. The main standard is the Wireless Distribution System, WDS. Wireless bridging can connect a wired network to a wireless network. A bridge differs from an access point. An access point typically connects wireless devices to one wired network. Wireless range extenders or wireless repeaters can extend the range of an existing wireless network. The security standard, Wi-Fi protected setup, allows embedded devices with a limited graphical user interface to connect to the internet with ease. Wi-Fi protected setup has two configurations, the push-button configuration and the pin configuration. These embedded devices are also called the Internet of Things and are low-power, battery-operated embedded systems. Several Wi-Fi manufacturers design chips and modules for embedded Wi-Fi, such as GainSpan. The main issue with wireless network security is its simplified access to the network compared to traditional wired networks such as Ethernet. With wired networking, one must either gain access to a building, physically connecting into the internal network, or break through an external firewall. To access Wi-Fi, one must merely be within the range of the Wi-Fi network. Most business networks protect sensitive data and systems by attempting to disallow external access. Enabling wireless connectivity reduces security if the network uses inadequate or no encryption. A common measure to deter unauthorized users involves hiding the access point's name by disabling the SSID broadcast. While effective against the casual user, it is ineffective as a security method because the SSID is broadcast in the clear in response to a client SSID query. Wi-Fi access points typically default to an encryption-free, open, mode. Novice users benefit from a zero configuration device that works out of the box, but this default does not enable any wireless security, providing open wireless access to a LAN. To turn security on requires the user to configure the device, usually via a software graphical user interface, GUI. Piggybacking refers to access to a wireless internet connection by bringing one's computer within the range of another's wireless connection, and using that service without the subscriber's explicit permission or knowledge. Wireless internet access has become much more embedded in society. It has thus changed how the society functions in many ways. Over half the world does not have access to the internet, prominently rural areas in developing nations. Technology that has been implemented in more developed nations is often costly and low energy efficient. Access to Wi-Fi in public spaces such as cafes or parks allows people, in particular freelancers, to work remotely. The internet has become an integral part of living. 81.9% of American households have internet access. Additionally, 89% of American households with broadband connect via wireless technologies. 72.9% of American households have Wi-Fi. Several other wireless technologies provide alternatives to Wi-Fi for different use cases. Bluetooth, a short-distance network. Bluetooth Low Energy, a low-power variant of Bluetooth. Zigbee, a low-power, low data rate, short-distance communication protocol. Cellular networks, used by smartphones. WiMAX, for providing long-range wireless internet connectivity. LoRa, for long-range wireless with low data rate. Some alternatives are no new wires, reusing existing cable. G.hn, which uses existing home wiring, such as phone and power lines. Several wired technologies for computer networking, which provide viable alternatives to Wi-Fi. Ethernet over twisted pair. Thank you for watching this video.